As long as robotics is seen as an application of the current underlying trend of a tech, it never becomes an industry by itself. The robotics has to be an industry by itself. That inflection point, humanoids have fueled it a lot. Compared to ever in the history, humanoids have created a lot more supply chain around them, have ensured that the robotics could be treated as an independent industry. But that formation of the industry would happen only when they are able to generalize and then understand from a problem point of view, not from the form factor point of view. And intelligence, while there is a lot of hype around it, it should start from the hardware. So form factor has to be first structured, and then that has to stabilize. That even when it happens, and the supply chain organizes itself around it, then that is the moment where the inflection will go. The potential has always been there. It's just a mindset and approach, a collective mindset and a collective approach.
Hello and welcome to another episode of Speciale Focus, brought to you by Speciale Invest, a leading early-stage deep tech VC firm. And I'm Hariharakli, your host. In this episode, Gokul N.A. and Nikhil Ramaswamy, founders of CynLr, talk about how advances in industrial automation and robotics portend a future in which factories can be repurposed entirely through software changes rather than expensive infrastructure overhauls. But, yes, there's always a but, and in this case, it's the need for standardization of hardware first. Then there is the gap between the vision for such autonomous factories and the challenges of building and training the machines needed for such manufacturing facilities. This in turn translates to building an entire industry ground up, and these two entrepreneurs are in the thick of it. From their Bengaluru headquarters to a Swiss R&D center to a customer-facing operation out of Austin, Texas. In this episode, Gokul and Nikhil give us a sense of current barriers to widespread automation adoption, which remain rooted in traditional robotics' dependence on precise external infrastructure. For example, today's robots require parts positioned within 0.2 millimeter tolerances, demanding extensive custom engineering for each deployment. This customization-heavy approach prevents scalable solutions and keeps automation economically unviable for most manufacturers. CynLr's founders advocate moving beyond the romanticized notion of robots as humanoid helpers. Instead, they position robotics as purpose-built tools for relieving humans of specific labor tasks, much like computers replaced arithmetic operations decades ago. This pragmatic view focuses on solving real manipulation challenges rather than chasing creative but impractical form factors. CynLr's multi-arm systems target the 90% of manufacturing tasks that remain manual even in advanced facilities. The company addresses the critical gap between current machine learning approaches and real-world adaptability by enabling robots to gather information dynamically rather than relying solely on pre-trained datasets. At the macroeconomic level, with aging workforces across developed nations and acute labor shortages emerging, the automation imperative has shifted from cost optimization to operational necessity. In this conversation, Nikhil and Gokul talk about how technical breakthroughs in on-the-fly learning and standardized hardware platforms could finally deliver the flexible, economically viable automation that manufacturers have long sought. I hope you enjoyed this conversation and find it insightful. So actually, Gokul, Nikhil, it's really wonderful to get you both together for me after quite a bit of time.
I think it's the first time after he has gone to US, that I am also seeing him now on video. So
yeah, he was just telling me that it's been a very recent move, just 2 weeks ago. 2 weeks. So nice, another point to talk about on the podcast. And thank you both for doing this. And welcome to Speciale Focus. I think in the world of deep tech startups in India and definitely in robotics, you guys have already made a solid name for yourself with all your achievements. For people who may not know about CynLr, outside the world of tech, for a more general audience, Maybe you all can start us off with a quick brief history of how you started CynLr, why you did it, maybe, and then we can go from there.
Okay. Oh, nice. Fine. Yeah. We started CynLr in 2019 August, right before the COVID onset happened, uh, which has created the tailwind now. But so the focus for us has been in the amount of barriers that customers face in adopting robots into for their automation purposes internally, and there's been a huge problem for a long period of time because robots currently are deployed from a very pre-programmed dumb machine sort of implementation. uh, but its maximum utility comes only when they are autonomous by themselves. They can figure out the scene by themselves, and there's a lot of missing technology gap in that whole space. And that starts from the sensing ability to knowing what to do with the senses, whatever that you've sensed, the stimuli that you have gotten, and then how to kind of operate in a scene, and that there's a gap in all of that. So that we carried as a problem all the way from National Instruments during our career at National Instruments, that when we worked. Um, so I was working as a machine vision specialist, RF embedded, and so on and so forth. And Nikhil was in the business development side of things, dealing with the customer problems directly on a day-to-day basis. And well, I was architecting solutions for customers across different geographies that NI catered to, which was Europe, India, Arabia, Russia, Taiwan, and so on and so forth. Specifically these geographies. So that gave us more insight into the common underlying pattern of problems that sensing and robotics and image processing essentially had, vision essentially had. And that's what we consolidated later into a common denominator of a problem, that when it comes to being autonomous about manipulating objects or assembling parts, or basically with any operation that you do to put pieces together, parts together, that's where the value is. Be it assembling your mouse or your spectacle or your laptop or your car, whatnot, all of them commonly have this one problem: replacing human hand in putting those parts together. So, and that has to happen autonomously. With that as the thesis, we kickstarted in 2019, and we worked hence from then to kind of productize and then get all the missing pieces of technology developed on and above it. So today we are a 65-member team across the and we have offices in 3 geographies, including, I mean, Bangalore is our headquarters. Design and development is based out of here, and we have our design center based out of Switzerland, and we have recently opened up a sales and go-to-market space in US, in Texas, Austin.
It's been 6 years since we started CynLr, but actually our journey as founders go a lot longer. So we've known each other, I think, close to 14 years now.
All through our career.
Yeah, so right
All
after
through.
graduating our engineering degrees, we joined NI. We were in the same team. We did take different career paths within National Instruments, thankfully complementing, or complementing in a useful way for us at CynLr. And then before we started CynLr, we did actually 4 years of bootstrapped consulting and services work in the same space in machine vision robotics, and that's something that we cherish a lot, because we spent close to 4 years, probably another engineering degree in the lap of the customer, spending days and nights in the factory floors, figuring out what their challenges are and what the gaps in robotics is. So those building blocks led up to us starting up in 2019, and since then, multiple rounds of funding and COVID, we've kind of surpassed all of those to be here at this point in time.
I've interviewed both of you a few times, but every time I forget, I meant to ask Gokul, what does the NA stand for? Gokul N.A.
The N stands for Namakkal, where I hail from, and A stands for my father's name.
But actually, it's sort of a misnomer, because normally in business parlance, NA is not available. Gokul is the most available person in office and at work, so you can't beat that. It's an oxymoron.
Fair enough. Which year was it that you all graduated?
2011,
2011. Okay.
2007 to 11.
Okay. Okay. And after NI, you've always been entrepreneurs, right? NI was the one place you both worked together. Can you give us a sense of today what is CynLr, becoming well known for?
Well known for essentially our ability to generalize automation. So our keen interest is in standardizing the hardware. So what we kind of want to achieve is a software defined factory than more of a hardware defined factory. Today factories are predominantly very much defined by the hardware infrastructure that you put in there, and the change from one factory to another factory, one product to another product. Our thesis generally and the technology that we build, which is including the robot form factor and so is more focused towards that application for the customer, where they could imagine the whole factory could be repurposed and transformed or modelly changed to produce something else just by change of a software. And that that idea that we actually push to the customers is what mostly we are recognized for. The other factor is obviously the product that we actually build, which has garnered quite a bit of an attention and interest from that point of view. The fact that we have a three-arm system that we imagined well before humanoids took into play, and then we started talking about generalization of hardware and general purpose robotics much before the humanoids came in. And our approach towards this whole intelligence space, where we are more focused head down than from the humanoid space, which is leg up, right? So we looked at what is missing in terms of intelligence in trying to understand the real world object, and those gaps that we address from sensing point of view and sense and intelligence point of view, and how you could do from manipulation point of view, is again another factor that differentiates us and makes customers kind of seek us out in this process. So, Nikhil, if you have
Yeah,
a
so
few other
from my
points.
perspective, I mean, what we are well known for from like two portions of the community that we speak to, right? So I speak to a lot to customers, I speak a lot to investors. So from a customer's point of view, today there's a lot of noise around what's happening in robotics. There's humanoids, there's AI, there's a lot of promise, and sometimes the promise, while it's exciting and it kind of creates a FOMO in the minds of the customer, there's a lot of mistrust also whether this tech is being looked at very foundationally. Off late, we've kind of managed to get feedback from customers that they're very confident with our foundational approach towards building things. So we're not just promising something. We're very foundationally thought, and that's something that has been the DNA of the company ever since Gokul thought of building this, right? So we have very first principles. We build what is practical, what matters, and then finally it solves the customer's problem and just not show off something that's sexy or that's good in videos, right? So that's one thing from the customers. From the investors, I think one thing that I do see people know us for, or know at least Gokul and me for, is that we are extremely persistent with what we have conviction for. So I think we've been very unwavering with respect to our approaches, regardless of what's happening.
And unapologetic also.
So that persistence has held up, and I think that's something that we will keep for the rest of our lives, because there's no point just getting distracted with what's happening in trends. And right from day one, in 2019, when we pitched, if you look at our seed deck, after all these years, I wouldn't mind pitching our seed deck even today. So that's how we've been operating.
In fact, that has become more in between. We tried changing portions of it because it was very hard to educate the investors and so on and so forth. Now, when we look back, considering the current trend and the awareness that has come around a little bit, both on the for and against the human things, our seed deck seems more relevant now than it was even at the time of seed for the case. So, one word that we can actually put is everybody goes back when they interact with us is the clarity. That they seem to appreciate the most with us. So at every point, they see that we do understand the subject more thoroughly, and that's what I think the depth that we have dived into this space is what is we are most known for, essentially,
Yes.
both from the customer's point of view in terms of how we have imagined their business transformation, not just the technology pitch on the other side. When it comes to the tech side of things, the amount that we have delved into the robotics and then what's the gap, technology gap within that space. So
This is a kind of good, to some extent, abstract, high level explanation of almost like what your philosophy is about. But tell us also about the product. I mean, because I've been a reporter covering your work, I know that there's a sophisticated hardware aspect to it, but there's also a solid software stack and all of that, and more AI being developed. But in your own words, give us a sense of what you might today see as your flagship products.
right. So from a product standpoint of view, what we have tried to do is we wanted to add as much freedom as needed for the machine to collect information about the space when it's insufficient. So today, machine learning operates on the premises that if something doesn't work, take that non-working data set, feed it back to the system, train again and again on them, right? So then you're going offline to be able to train and then come back to it. So what I've done with our product is the ability for the system to, if I give you a coin, if you're not able to kind of sense what is written on top of it, you don't take that image and go back and train yourself. You just tilt it. You just look from different angles, right? So till it is very clear for you that I can what is written on top of the coin or embossed on top of the coin. That freedom for the system to collect information in real time by itself, so that it can act not without being stalled, is the primary aspect that you have actually built into the product. That starts from the visual sensing to the multi-hand operation to the ability for the head to approach from different angle point of view and viewpoint of view to act on them, and what we call as a whole stack of dynamism in both in terms of the uh, sensing the environment and also towards acting the environment. So it kind of mirrors what a human upper torso actually has, but at the same time, it also adds more freedom than what a human upper torso actually has. By putting three arms, it's one of the very few systems that has imagined three arms with and two arms handling the objects and one arm handling the visual, feedback that comes out between them. The second aspect is the level of coordination that happens between both the hands and the way they could interact. Like a very simple task, if I want to pick a pen and then put a cap on top of it, uh, seemingly very simple task for a human being. For a robot system, it's a very complex activity. Being able to pick a pen and a cap, and then knowing what orientation it is, whether the right hand is supposed to move or left hand is supposed to move, and taking that call and decision in real time, and then left to a robot to take that call is a very very large problem and very complex problem. So all these missing layers of stacks in intelligence is what we built, what we call as an object sentience, and the resulting product or a platform is something that we call as a object computer. The form factors is called Cyro and Cynoid, which are mobile platforms. So yeah, so this is the broad overview of what we actually do with the products. Nikhil might be able to add a little more clarity in the way I actually said than I mean, he pitches better than I do. So
Yeah, so the technology that Gokul described, what that really means. I mean, if you, I'll try to kind of translate it to what the customers really see, right? So, what that really means is a very intuitive, dual arm vision guided robot product that is highly scalable to performing different tasks, right? So, in a factory, a worker is using both their hands and then assembling things, right? So they're picking an object from one hand, reorienting them, picking an object from the other hand, reorienting them, placing them. While placing them, they're like feeling forces. They're like understanding how to mate objects. While they're picking, the objects might have moved around, so they need to kind of see and understand where it is. Lighting might change. Now there are so many of these scenarios. So every single product that is being manufactured goes through a lot of these variations that needs to be handled. Human beings just does it very intuitively. We don't even think, we don't even like realize that we are doing it. What Cyro does is it provides a very scalable vision system which operates very similar to the human eye with eye movements, change of focus. It can look at objects at different distances and then use both hands to configure for different tasks. Like Gokul explained, like a computer, you can write programs where you can configure n number of different tasks, whether you're assembling the doorknob of a car, or let's say putting together an iPhone, or building any other part, you'll be able to reconfigure the same things. The platform Cyro, and the mobile version of it is called Cynoid, is basically built so that it becomes easy for the customer to build these tasks and progressively automate assembly and other operations, which actually is contrary to probably what popular media might present. In factories, there's very little automation today, right? Like a typical car plant has less than 10% of the tasks automated. 90% are still manual, be it in Germany or in the US. So all of these tasks that were previously too difficult to automate, we start automating with these platforms and all the tech progresses that foundationally we've built over the last 6 years.
Hmm. You already have some very large multinational names in the industrial world who are using your tech products as well as software. Can you give us an update on that and tell us a bit about what are some really interesting use cases that they've been applying Cyro as well as the I think CLX01 as your vision stack? What have they been using all of this for?
Yeah, so largely our traction has been with doing what we call as these transformation pilots, where a large enterprise, somebody who's running a very large manufacturing or logistics operation, is looking at automation use cases that are thematic in nature and very large scale in nature. So at this point in time, we have bucketed into, in terms of sectors, it's largely discrete manufacturing, which is companies that are building products where discrete parts are assembled together. So it could be a car, which is a very sophisticated product, or an aircraft. It could also be smaller electronic goods, smartphones or laptops and other servers and server racks, etc. Right. So discrete manufacturing is one, and then associated with discrete manufacturing is the supply chain for discrete manufacturing. So you have warehouses that supply parts to this discrete manufacturing, and then we also have interest in, but we don't have enough traction yet in the retail side of warehouses, which is your distribution, your Amazons and Walmarts and FedEx and DHLs
E-commerce.
of the world. But primarily, our adoption has been with discrete manufacturing and supply chain attached to discrete manufacturing. Within that, automotive, semiconductor, electronics. So we've been working with customers like General Motors, Denso. We will likely begin working with companies like Audi, and Applied Materials. So in all of these companies, we've been building dual arm assembly tasks, or warehouse handling tasks, all of which were previously manual, like human operated, even in the US or in Germany. And these were tasks that traditional robots simply could not handle, because there's something varying about how the part comes, or there's something varying about the part's design over a period of time, or it is just too cumbersome to put traditional dumb robots. It's too large to put a machine there. In our case, we can just kind of put a robot in the place where the manual worker is working, without changing the infrastructure, without the customer having to reinvest in infrastructure. So we're running some of these pilots, which will result in an automation transformation for large enterprises.
So primarily, we have three form factors of products. I'm also combining the answer for the three ones in a more crisp way. So we have a visual platform, visual and sensing platform, which is called CLX, which powers the multi-armed system, which mimics the upper torso of a human being with all the freedoms and movements and so on. So called Cyro. And the third form factor that we'll be releasing in the next year's first quarter or so is called Cynoid, which is completely mobile with the multi-arm capability. So it packs more freedom than what a human body can actually operate with, and more sensing and faster reflexes than what a human body can, react with. So all these are targeted towards one particular application or one particular value called object manipulation. In object manipulation, specifically mating parts, wherever you need to pick, orient, and place parts, that's where we largely come into. And that's a completely unsolved problem today. So that's where we said, including assembly of your mobile phone, to even picking a bolt and putting into a screw hole today is an unsolved issue, right? That's a completely open space. So in that, the mating is only two types of task: either you're screwing or you're press fitting two pieces, always. uh, like your pen assembly or your pen, you put a cap, screw the cap, right? Like that. If you think about your laptops, your car, most of the actions are moving these items and fitting them together, right? So we are application agnostic from that front, but we have customers now within automotive sector and also with semiconductor and server assembly. So we are right now attempting one of the use cases with door assembly, the automotive car door assembly entirely for a German customer. And we also have one of the largest semiconductor special purpose machine suppliers for whom we are building a server. We are assembling a server rack. So the robot will be able to put together a whole server rack within them. Apart from this, we will also have a large segment of handling parts in warehouses, what we call as kitting, like picking parts from in its original state and then making a composition of a kit to be supplied to the further manufacturing for people to assemble, pick and assemble that. So preparing those kits, and we are also exploring inroads into while these are some things that we are working on, the next ones that we are attempting also and to kind of solve are what we call as feeding to the machines, called machine tending, uh, fitting the parts into the machine, press stations and so on and so forth, so that other machines can process them. So today these are all manually fed, and it has to be adjusted and then fed, because you have no control over how the input feed comes. Let's say if I want to feed a sheet and then the sheet has to be bent for your car, parts. So today they you have no control over how those parts come. So only a human being is equipped enough to adapt to all those variations and then feed it to the machine. So instead, CynLr Cyro platform is more equipped to kind of feed them into in those machines. So these are the key applications that we are exploring. We will also kind of right now our capacity is to explore only in this space, but eventually we will start looking to expand into further spaces, more interesting spaces like lab automation and energy sector if possible, and so on and so forth. So
Hmm. You've spoken about a lot of the things that are currently not possible that you are solving on the technical front. If you look at it from the customer's perspective, um, I mean, sort of in a big picture way, can you give us a sense of what is happening in their world? I mean, everything from the economic uncertainty to how the market dynamics are changing. For example, in semiconductors, some of the Western companies are already moving away from the low value add SOCs, and that's an opportunity, and so on for Indian design companies. Similarly, can you give us a sense of some of the factors that may be coming together in your customers' world today that makes a company like CynLr very relevant or is a big opportunity for you?
I think I'll split into two things. Right now, the question that you're asking is the current context of what's happening in the global center, and everybody. I just dropped out of a World Economic Forum call before joining here, and the talk was all about Trump's tariffs and what is happening within them. But I think that impact of that, the whole industry is still grappling to see what they are supposed to do and how they want to kind of react. Right. First of all, they were hit with a supply chain issue right after the COVID, and though COVID was actually thinking, I mean, there was a lot of hype around work from home and all that, but supply chain. We were always predicting the supply chain will become the actual necessity. That's a foundation for any system to exist. Now that has become a national security issue, and many of the developed nations are now waking up to that reality, and incentivization and schemes are happening in a very different way on one side, and finally the labor cost arbitrage has crossed the cost of technology today. So robotics was suffering on that front too for a long period of time, where the cost of robots remained higher than the labor cost even in established nations. Uh, so, but while while that is the arbitrage that gives you an advantage to bring them in, which is a no-brainer for you to think and then bring them in, where we can actually today we can give it at 1 year ROI for a customer, 1 to 1.5 years of ROI for a customer. Customers are waking up to a very different reality of wanting to keep their factories more resilient. My capital investments that has gone into today, I am stuck with capital investment to be recovered from my factories. And any automation or even factory as an infrastructure, basic infrastructure to be operated by human beings also, is a very capex intensive setup, right? And that consumes more to 5 to 6 years for me to kind of recover, and that infrastructure is not modifiable till that point that I recover this money, which means my design of my product is stuck within that framework of what I put as an infrastructure. So I can't just keep changing my designs to the wish of what my consumers need. And the problem is this recovery is 4 to 5 years of period, whereas consumer needs are evolving too fast at this point, where every year their tastes are changing, their expectations are changing, so they're not able to cope up to it. So it always is a problem of not funding the market creation or demand creation, right? So where it's always becomes a marketing sales problem, but also creates a space for someone else new to come in and then start with a very fresh set of investments and then disrupt their business very quickly, right? All this goes away if their both their supply chain and their infrastructure can be very nimble. So that nimbleness is something that they are looking at. A modular factory is something that, as a concept, that actually makes them think more, because when tariffs also hit, my supply chain material also changes. So what I'm supposed to produce with also changes. Now my infrastructure doesn't permit me to be adapting those things at a very quick pace and be able to kind of recover onto that. So this is a topic that is coming up. How it's being implemented, how they are going about doing it, is something it's yet to be discovered. But one thing is our narrative, and then the reason why we want to give the robotic arms not as a person replacement or a labor replacement, but as a unearthing the total potential a manufacturing has in terms of being able to capture a larger market than what they can cater to right now, only through a product design right now, is falling much more easily into the customer's ear, and it's resonating much better with the customer's ear now. So that's one transformation that we see. There's a lot more seeking out that's happening because of this to technology like ours. I wouldn't say ours is the only one, but they are scouting for such tech at this point. So that's one difference when we interact with customers that we notice.
Yeah, maybe I can add a couple of things from my observation in the United States, which I've just kind of like I've been spending a lot of time in the United States traveling and now full time for good, right? So in the United States, a couple of misconception is that manufacturing in the United States is not as automated as we would like it to be or we expect it to be. There's a lot of dependence on labor in manufacturing as well as retail and warehousing. Just this machine tending that Gokul was talking about is basically a shop which is making parts either for automotive or other industries, metal or plastic parts. I think there are probably a million and a half, 1.5 million workers in the US that currently are working on just machine shops. And if you expand that to assembly and retail and stuff like that, it'll be like tens of millions, right? So these jobs are not automated; they're all manual and needed for the backbone of the country to kind of survive. These jobs will increase the requirement. When I say jobs, the tasks that needs to be done, as I think over the next 10 years, over the next decade, I think the open jobs or new job creation for manufacturing and manufacturing workers itself, I think is in the fives or tens of millions, right? So at least 5 million. These jobs are not getting filled. The reasons that they're not getting filled is, one part of it is that the current workforce is very aging. So I've been to GM's plant, I've been to Ford's plant. Gokul has been to a lot of European manufacturing plants. And one of the things that you'll instantly observe is that more than half the people would be more than 50 years old, right? And that means that in the next 10 years, they're all going to retire. And there aren't people that are willing to come to fill these jobs as well as fill the new jobs that will be created over the next 10 years. And there are other driving factors why people are not willing to come to factories for. There is better economic opportunities in cities, mostly in gig
Gig working.
works, where there's a lot more flexible times. Like you would rather drive an Uber or not deliver for Amazon than you would work 6-hour shifts in a factory condition, right? So a lot of these labor dynamics sort of has made the country realize that over the next 10 years, um, manufacturing is going to suffer from acute labor shortages. And and again, because of the geopolitical situations, there is a real need for the US to bring its manufacturing back on track and really have manufacturing done here. And what that really means is automation is the only way to go ahead, right? So the driver for automation is very palpable. Like anybody and everybody is interested. Even a machine shop which
Yeah.
just has one or two machines will say, "Hey, if you can give me a robot that works, and I don't have to keep calling you for every single part that I change. I'd like to have it yesterday." But that technology does not exist yet, and or even if it exists, it's nascent. So we are kind of in that early stage. So that's the biggest driver in the US, and similar trends are also surfacing in the UK or Germany, or Japan or Korea for that matter, which are all heavy on manufacturing, heavy on current manufacturing install base. It's going to have a tectonic shift in labor dynamics over the next 10 years. And that's where the automation demand is really rising from.
And on the flip side, Gokul, when we started the conversation, you talked about the barriers to adoption. You made a passing
Yeah.
mention. So, on the flip side, today, what are the most important barriers to an accelerated adoption of robotics in general, especially in the industrial scenario? I mean, let's leave aside the consumer side for now.
The primary barrier is the dependence on external infrastructure and structuring for robots to be working. Simplistically, in a very simple language, robots today operate at zero point 0.2 mm of repeatability, accuracy, and repeatability, precision, basically. Which also means that the part it is supposed to act on also should come within that zero point 0.2 mm of tolerance. Now, ensuring that all those parts that you supply to the robotic arm to come within that 0.2 mm of pre-programmed position is a complex engineering problem, and it consumes anywhere between like 36 months to 15 months for you to kind of design all of that, prove it. By the time many of the parts in themselves change, the part dimensions change, or they get upgraded, and so on and so forth. So this is the primary barrier for customers to adopt the robot systems. So the amount of customization, the value in the solution remains largely at outside and customization. And customization simply means that there is no proof and validation that it may work. Which simply means that for every case it's very unique. And if it's very unique design, it also has to go through a lot of risk. For a customer, then there is very less guarantee that the automation will, at the end of the day, end up to be commercially viable for them, right? And it will work to that extent. Even if it functionally works, whether it will produce at the same rate that they expect for profitability, and lot of issues, that will work consistently or not, and so on and so forth. If parts are not available, then what happens? If that machine breaks down, what happens? There is no elaborate support system and ecosystem, and so on and so forth. All this builds into a barrier for adoption, and largely comes because of customization. Now, if on the other hand, it was standardized to a large extent, and it gets into a factor of simplification for them, the business becomes more simplified. So that's what we keep saying. We want to make factories more boring, and not automation to be very boring, in fact, right? So it should not be very interesting. Today it is very interesting. That's the problem, and you need a lot of engineers to do that. So
Mm. So, if you were to sort of sum it up in a line or two, to your mind, the biggest barrier, is it a technical one, operational one, or a business one, or a bit of a combination?
all three
Mm.
starts with business. Ends in technology, because that's the gap that is not allowing you to
Mm.
solve that as a business problem.
Yeah, if I may add, the solution is probably largely a technical one, right? So I think everything will get fixed automatically if the tech is fixed, and yeah, I think
So
that's what we are
Mm.
planning for.
But by and large, now we are seeing, especially in the last 6, 8, 10 months, definitely a lot more attention to robotics. I think JP Morgan's latest technology report actually highlighted this whole like a lot of people paying attention to robotics and so on, and there were some numbers as well in terms of how much money is going into it. That said, would you say that the a good inflection point from where you can see really sort of a big jump in adoption, more mass adoption in industry, how far away would you say that is?
I don't know to predict it in terms of timeline, but we can definitely say in terms of an event that would, what is the event that would trigger them, right? While there is a lot of excitement around, this is all just driven largely because of Nvidia's push and the market capitalization that has happened around Nvidia, and that mobilizing a large amount of funds and then humanoids coming in. So there's a whole trend that churned in a very, very convenient fashion, right? So this, you would also remember Boston Dynamics at one point, and this is always is, the cycle keeps going up and down, up and down. So for me, I've seen this for 15, almost 25, 20 years now, 20 plus years now. So this is this is like the third time or fourth time, maybe third time, and that I'm actually seeing the spike come in between 2015 around one, and then 2007 to 11 one, Dynamics time, 15 16 again, intelligence time, then again now it has uh, resurfaced again. So but at the end of it, the problem is not coming backwards from the object. The problem is coming from forwards from application of tech. As long as robotics is seen as an application of the current underlying trend of a tech, it never becomes an industry by itself. The robotics has to be an industry by itself. That inflection point, humanoids have fueled it a lot. Compared to ever in the history, humanoids have created a lot more supply chain around them, have ensured that the robotics could be treated as an independent industry. But that formation of the industry would happen only when they are able to generalize and then understand from a problem point of view, not from the form factor point of view. Currently, the trend is running from, hey, we have tried solving with so many special purpose machines and nothing is solving. For a general purpose, then go ahead and just imitate a human being. Don't do cost optimization, nothing. Convert that into a supply chain problem. Just ensure that you have all the freedom that a human being has. But they're sensing, but they're approaching it more from the freedom. How much of movement freedom, how much of movements can it have like a human being, than from how much of sensing like a human being that it's supposed to have. So that is the inflection point for the system to remain as the common form factor for wide varieties of applications. So that is yet to happen. That, from a technical point of view, that will be the inflection moment, and I don't think that has arrived yet. And intelligence, while there is a lot of hype around it, it should start from the hardware. Uh, See, x86 architecture came long ago, right? So, but for us to convert that into a machine learning, it has taken 30 years. So form factor has to be first structured, and then that has to stabilize. That, even when it happens, and the supply chain organizes itself around it, then that is the moment where the inflection will go. It is potentially, the potential has always been there. It's just a mindset and approach, a collective mindset and a collective approach.
Mm. So let's get into some of this. You mentioned humanoids, NVIDIA, and therefore let's talk about AI.
Mm.
And I think very,
All
very,
the trend
yeah, yeah,
topics.
yeah. So very, very recently, some really interesting stuff. I mean, there was the Boston, I think it was Boston Dynamics and Toyota Research. Was it a
Ah,
nice video
that's right.
about
Yeah, 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 yeah. They did.
a
Yeah,
robot
yeah.
where they created obstacles deliberately and
The king and them.
the robot was still able to do something. And then I think you alluded to the training. I think there's been a technical paper. You guys would have read it about this debate on whether the training with a lot of data can be done, or it still requires a lot of engineering, real engineering.
Correct.
I think there are two
Around it.
schools of thought on this as well, right? Something called the 100,000 year problem or something like that. Yeah.
Yes, yes, yes.
Um,
Yeah.
can you give us a sense of where you stand on this? I mean, just explain
Sure.
this to us in layperson's terms. What is the debate, and then you can talk about humanoids.
So basically, I mean, removing all this, there is this two aspects. One is the black box approach, that there is something called as holistic intelligence, and there is one universal thing that does everything. On the other hand, there's another school that says There is meticulously broken down dumb systems, but when you allow them to be flexible enough to arrange by themselves on based to case basis, then they give you an appearance of intelligence, but they're able to solve complex problems, right? There is a flexible system here, and there is a very rigid, pre-trained, pre-programmed system here. So that's a debate that is going between these two scenarios, right? So there is, I mean, our school of thought is also is very similar to the later one. We don't think there is one large format of, one black box called neural networks. There's one holy grail of a neural network that is somewhere existing, which will solve for every cases. We need to kind of model even your brain. Each portions of your neural blocks do not understand what the other block is doing, but yet when needed they will flow between each other, and somehow they will handle a very large complex problem. And more complex a problem that you're able to solve, the more intelligent a system is deemed to be, right? And that's most often, so in physics we have something called as causal physics and observational physics. Observation, classical physics is predominantly or observational, like what it appears to be, and then I'm trying to encode that appearance behavior, formulate their appearance behavior. What causes it? It's a very different thinking, right? So we are looking at what causes intelligence, then what appears to be the intelligence on one side, right? The other factor is on the fly learning, otherwise called a zero shot learning technically, but I call that as an on the fly learning, right? So like a baby, without having to have prior training, millions of data to be already gathered and then gained and then come back and then look into the real world scenario, it's not possible in every case. And you can't have defined for every corner case possible. You need to let the system learn on the fly right there for every scenario and bring it back. Like if I present you with a very unfamiliar situation, you will try to look for cues. You will interact with that situation. You'll pick the objects there, pick it in your hand, rotate and look at it to see where it makes sense, where it is familiar to you, so that you can act on top of them, right? So from an unknown case, being able to act on a very unknown case and then bring it back to your familiarity is something that has to be part of the machine in itself, right? So suddenly I have trained this mouse only to be looking like this. Suddenly I put a plastic wrapper on top of it and then present it in front of the robot. Will the robot know now what to do, right? I do not know. I have not trained for how to remove a plastic wrapper, but somewhere within, it's also able to notice that there is a mouse that is there. But can I go and touch that plastic wrapper, pick that, feel it, pick it, and then see once I remove the plastic wrapper, suddenly now it looks like a mouse that I knew before. Now I know what to do with this mouse, right? So for me to get from an unknown situation to a known state, right, is what we call as an on the fly learning, that the system must pick it up by itself on the fly, right? Which is a largely absent space. We asked this previous question, when the inflection point will come, when the robots are able to learn on the fly. It's not just the form factor, it's not just the tech layers and all this that we actually talk about. If the capability of the robot, without, for all cases that it has not been trained for, it can decisively act on them, right? Like a baby without knowing what it is doing, right? But it can still act on them and then figure its way to get to a known situation, right? That it has been trained for, right? That is what, when they become highly useful to the customers. Now they can use it, repurpose it wherever they want to, and they can comfortably replace a person with that machine, that it will figure out and then complete the task. Today, they're not able to adopt. The inflection is not happening because customers are not confident that if I put a robot, I can remove a person. Or I can forget that the task will, somehow the robot will figure out to do the task by itself. A person does it, right? What are the situation, Mimi? You give them as an end task and a goal, the person is able to do it, right? He will figure out his situation. If your pen cap fell down and then went under the machine or under the table or under the bed, which you have never trained for, your person will go and figure out how to pick that back and then put that cap and then finish his task, and then put it back into the assembly line. Would a robot know in that situation? And how many such situations will you go on training, right? So training is not the answer for such situations, and especially when it comes to real world scenarios. The robot's ability to learn by itself is the answer for it.
Mm, mm. So, does that hold a clue in terms of how you see the future of CynLr, in the sense that do you see your products and technologies evolving in a way in which your software stack will allow your hardware form factors to kind of self train, and where are you at on that journey today?
Right. So, I mean, it's not just for us. I think anyone in the technology space, um, uh, software is the one that mines the utility out of what you have created as a hardware platform, right? But the utility is where the value essentially lies in. And for us, when we said we want to generalize a complete form factor or a complete stack that allows you to do object manipulation given any situation, any scenario, right? So, what we are further investing into developing is all the layers of sensing that is missing in robots to be able to act on them. Uh, all the layers of intelligence. So we try to build even our neurons from scratch by ourselves. So what we call as physics informed neural networks on one side. So that basically is nothing but an equation that can self tune itself into existence, right? So mathematical, I mean, physics equations that can. So the modeling the physics of an object and then bringing back into the system, and then modeling also how the brain approaches the physics of the brain, not in terms of how we have formulated and then put an equation to. Like when we formally learned, we talk about force, we talk about mass, and so on and so forth. That's not how our brain goes about interpreting this object. It goes and handles this. So that brain's physics over this particular object and how it handles them is what we are trying to kind of you know shamelessly imitate into the machine. And then more we bring in, what we are bringing in as an ability, like a baby, for the system to go and pick, learn, and interpret the real world by itself, right? Touch, see, and feel it by itself, right? Once that is there, then they become very highly task trainable. So this is where we are going towards. We will be creating something called as an object store and an object module, and we'll also be creating something as a task module. And task module is always is human informed and human trained. So whereas this object module is something that the system can learn by itself. You put any object in front of it, it will figure out how to kind of pick them, how in a different orientation supposed to handle them, and all that, right? But once that is there, now let's say it's a screwdriver, it has learned how to kind of pick, handle all the screwdriver. But what you are supposed to do using the screwdriver, how you are supposed to place on the screw, how you are supposed to turn the screw, and all this are tasks that you will teach on about them. So we are going towards this line. And what you would see us do in the future is to bring more ability of sensing within the robot system, that it can go and handle a lot more complex set of operations and activities by itself, and by virtue of which the system becomes completely task agnostic and object agnostic. So then what it dawns into a concept that we call as an object computer, like how your data computer in your you have seen this famous meme on a desk. There were so many varieties of machines, your fax machines, your phone, your calculators, whatnot, right? All of them merged into this one single form factor called laptop, right? Similarly, what we work towards, or what we are trying to achieve, is one single form factor of a hardware that solves for all varieties of tasks that you may face. And then that opens up another full paradigm, like how your whole software and IT was created. It'll create its own an object-oriented paradigm of software development altogether, entirely, right? Not the OOPS, but yeah, the real-world objects, material-oriented paradigm of software development and machine learning development. So that's where we are going to get into. And what we believe the future of IT services will not be somebody sitting in front of a laptop, but somebody sitting in front of a robot and training the robot to do certain tasks. And he'll not be inputting through a keyboard, but he'll be rather inputting through a touch sensors and human haptic sensors, which will make the robots move and then start to learn and then pick objects and so on and so forth. So
Can you both explain the decision to build this universal hardware object or device? I mean, that sort of immediately caught my attention. Why? What is behind the decision, or your thinking that this eventual product will be a hardware device, and why isn't it a software product?
No, I think, yeah, I'll give it from my perspective. I'd say I would have loved it for it to have been a software product. Would have been much easier for me to.
all of, yeah, even we would have, yeah,
Would have
correct,
been
yeah.
much easier for us to have raised VC funding. All
I mean, obviously, I'm thinking in terms of, if it's a software product, can it go into a humanoid or even AMRs
we
and
can.
all of that? And that means your market becomes that much bigger and whatnot. Maybe I don't know. That may be the wrong track. That's why I'm asking you to sort of explain the rationale.
Yeah, so I mean, the our decision has not been like a personal choice. It has been driven by what we acutely observed in that period of time during NI, as well as that 4 years working with the customers, right? So the only reason we're building hardware, or we built hardware first, was because equivalent hardware to enable universal manipulation was not existent. So if you go back, let's say, 30, 40 years, you can't build an OS unless somebody has built a microprocessor, right? And then you have that memory infrastructure, and then something for the OS to run on, right? From a PC point of view. With respect to manipulation, there were core missing gaps in particularly the perception tech, as well as some sensory elements of the arms and the fingers, that we realized when we were doing work for local manufacturing companies. Like we used to work with this company called CynLr, which from an Indian context was like a prolific adopter of industrial robots. So they are like the largest adopter of Fanuc robots in India, and probably comparable from global standards point of view. So we could kind of really sense that existing robotic arms lacked some of these sensory elements. The existing vision systems that we had a lot of purview, and especially Gokul had a lot of purview from the time at NI, um, in his role as an architect for machine vision and embedded systems, lacked certain capabilities that were needed for us to build that universal hardware infrastructure. And therefore, we said, okay, hey, our goal is to build that software infrastructure, the object store, task store, which will make everything universal. We need an enabling computer to allow us to do that. Uh, it, and today we've kind of demonstrated that we've figured the hardware, at least hardware form factor, and some elements of what we promised as the software features are able to be realized by the customer. In the long run, there is a good chance that the rest of the world will also converge, realize that some of these hardware elements are quintessential and necessary. And if that convergence does happen, there is a good possibility, or a good chance, that our software stack can be expandable or extendable, right? And that's left to market to kind of determine. So if market remains stubborn and says, hey, you know what, we will not build the hardware that's required, and says that to build a supercomputer on a processor that can do only basic arithmetic, then we will be an Apple. We will say we will build the hardware, and we will also own the software. If the market does realize and then converges in a rapid way, so that hardware becomes more commoditized to run software elements that we have built, then we might want to transform ourselves into a Microsoft, or a somebody that can provide the software layers, right? So that's my perspective, and let Gokul delve a little more deeper on the technical philosophy behind building it, and also some of the core, like his perspectives into the problem itself has been very, very foundational, has been several decades in the making for him. So from that point of view, what he saw as critical gaps as to why we have to build the hardware, maybe he can pick that up.
So I think see, basically this is what it is. Software runs at every point of inflection in software happened on the basis of some hardware being stabilized. There has to be a standardization of hardware for software to take off, right? At the end of the day, we don't care whether it's a hardware or a software. Value is in customer utilizing that, customer deriving some utility out of whatever that you built. That's when there is value. Otherwise, there is just a whims and fancies of me doing hobbyist projects, right? So if I work backwards from the customer's utility, then we ask, what is that? What is it that is missing? If for 60 years somebody is not able to solve this particular problem using robotic arms to be able to pick and place an object or mate an object, solve a complete automation with a robotic arm, then there must be something fundamentally missing. What is missing? It's not some engineering genius missing in all of these cases. In every point of time, people try to solve using what is available. They never thought, what is missing, right? In what is available, right? If something has been unsolved for this long a period, then it must be a problem in our understanding of the object as an entity, not about something somewhere in engineering, robotic arms, or programming, or code, or whatnot. The world is still moving on that side. If you look at what is missing from the object and its nature that you have to handle and tame it to however you want it, and what am I missing in those cases? Then we start looking at, okay, is that, so we know what is the algorithms and things that we have to build, and and that algorithm, what kind of information does it demand, what kind of sensors does it demand, what kind of operations and manipulation capabilities does it demand, and then that what kind of compute does it demand. Do I have all of that available? If it's already available, then it's only an algorithm implementation, software implementation. If they are not available, then I'm supposed to go back and then start building them from scratch in the way that makes it possible, either from scratch or integrated. If it's not integration possible, then you have to go back all the way building some of the fundamental components also. So we worked backwards from there, which resulted in the fact that obviously there are a lot of things that are missing in this case. And whatever I'm building in, and today in terms of software, some pieces can be adopted piecewise, can break it down and then can adopt possibly for ADAS. Like what we have done in visual platform is highly relevant for what happens in ADAS. But my camera is not. The technology, underlying technology, when we license it, someone can build a camera as a form factor that fits the best for those. That's like difference between an a two-wheeler, a mobile phone, and a laptop. All of them are same compute platforms. A tablet, but you need them all in three different form factors for you to kind of consume them, right? Similarly, what we have using a visual, but all of them are ARM processors at the end of the day, right? Or x86 processors at the end of the day, right? Similarly, our visual technology is useful in multiple different places, but the product that we built was very specific to object manipulation alone, not for AMRs and so on and so forth. So one. So that came from the fact that these are the hardware gaps that you actually have. Oh, I don't have something like a RAM. Oh, I don't have something like a USB port. I don't have something like a webcam attached to my laptop, which allows me to transform this laptop into a remote call that you're doing today now in this, right? So otherwise, you have to have a different machine for it altogether, right? So that standardization of hardware didn't exist, and that's what we are trying to arrive at first. Only if that happens, then comes the software industry. Before Microsoft can happen, Apple happened. Before Apple can happen, Xerox and IBM happened, right? So that journey is still to be built, right? And then we have to look forward towards what is the utility that I'm driving for my customer, right? And there is a point that at a point, either because of the constraints, every organization, in even though they may cater to the same product like a Pepsi and a Coke, the constraints within the organization will be very different, so the business model will also be very different, right? So right now we are at a technology exploration space. How we should shape ourselves to be more towards an we will license all of our hardware and someone else will start building those hardwares, or we will standardize them for different reasons, that we see more potential in the software later, that we would just want to kind of open it and give it to people so that more people will proliferate on the hardware side of things, and rather we can just focus on the software. It'll all be strategic calls that we will take at a later point of time, but right now our focus is to um, you know uh, unearth this whole potential, a large underlying market that is available there, and that has to come from a technical form factor. And today, customers need solution, technology, and I have to jump all the way to solution. So there's no productization that's happening in between, or a platformization that's happening in between. Because of which, then I have to go like an Apple today, giving a full-fledged experience to the customer, than saying that, hey, I'll give you a software independently, I will give you a hardware independently, you figure out how to kind of integrate them together. So, and there is no know-how or experience with even with the engineering space to be able to put them together in a certain way. So all this drove us to the point where we have to do it all together as a stack, not just do only on the software. First of all, we can't do only as a software because we don't have a hardware available for it. And even then we have it, then we can't either stay as only hardware company or software company. We have to give it as a full stack altogether to the customer, for them to, as a solution, in fact, not even just as a full stack, for the customer to be able to experience it, and and see the taste, the utility of it.
Hmm. So, in that future, in the coming years, do you have a sense of what the hardware form factors will be like? I mean, will they be like robotic arms, or can they be humanoids? I don't know. I mean, or all of the above. How are you looking at it?
So now, see, I think practically, right? Has evolution given us one form factor? It's the same earth, it's the same vegetation, it's the same environment. I share the same airspace as the bird shares, right? I breathe the same wind and air as what the bird shares, right? I share the same earth or a ground as what a rat or I or a snake or an elephant shares, right? Each of them are purpose built for, they are also general purpose to a large extent, right? To a significant extent. But they have certain advantages to their environment and scenarios that it has been posed. Even for a human being, do we have, if you enter a kitchen, do you cook with your hand or do you cook with your knife and all those tools that are there around you, utensils and things around you, right? Have we created a car to mobilize us from one place to the other? Have we transformed the earth by laying down a plain road and a tar and so on and so forth, right? A metro railway. So I don't think that you will have an ecosystem of these robots. It will be like a metal ecology that you'll actually create, right? Made of this. I don't believe there is one holy grail of a form factor for all of these. They will have certain advantages for certain cases, but what you will converge into is a common set of such form factors, right? Like mammalian form factor is very common. It's all rat and then rat's own formations in into herbivores and so on and so forth. That specialization that they will get into, right? But the underlying form factor is very similar. Insects have a very underlying form factor, the torso and the three segments of the body or two segments of the body and so on and so forth. So like this, you may have certain foundational form factors. And you'll have multiple products proliferating out of them. Just like you have ARM processor and you have so many varieties of phones. You have so many varieties of devices, your DTH, that this and your mobile, your TVs and so on and so forth. So you have special purpose utilities, but they will originate out of one underlying form factor in between for some time, right? So one thing I certainly will, what I see will happen is you'll have a highly modular form factors where it will be very easy for you to attach more hands or remove hands, attach more legs or remove legs, attach more wheels or so that modularity kind of to reconstruct, but they all will seamlessly integrate with each other because of standardization will arise between them and will let the customer experiment more within that and then be convenient with whatever it is. Basically because of cost I want to reduce the amount of freedom, or maybe because of speed has to be more higher. So all these different cases might require certain kind of specialization coming out of these form factors. But the underlying form factor, you will have a variety of fundamental components. That's where I see it going, even though the current fight is more about which is the holistic form factor and so on and so forth. I see you had a monitor, CRT monitor, right? Then came a TFT and LCD. Now we have a full laptop form factor. Nobody even has a PC anymore, to a large extent, right? So this will happen, and all these compositions will actually happen. So I don't think there is one thing to win the war. In fact, they will break down into a bunch of ecosystem of these components.
Yeah, and just to add to that, I think it might help for folks in the ecosystem, especially in robotics, is to de-romanticize this word robot, right? So this robot itself,
Yeah,
it's a
yeah,
very
yeah.
very glamorous word and like a very catch-all word. At the end of the day, I think it's easier for us to digest all of this if you're looking at what utility we are creating for the society, right? So at the end of the day, there is a constant pursuit to relieve human workforce out of certain jobs and certain tasks. We relieved human workforce out of computing and doing arithmetic operations with computers 20, 30 years back. So today we don't really have to do that, and we're able to do a lot more than what the human brain can do in a specific, and there's a specific machine that enabled you to do that, and there's a specific amount of software and intelligence that is even continuing to evolve that allows you to do that. From the world of robotics, the utility really is to relieve human beings of labor that involves manipulating the real world and objects in the real world, right? So that is the primary subset of machines where the robots really come into play, or robots as we colloquially call it really makes sense. We are moving material, we are handling material, we are manipulating materials, and that's happening constantly day in and day out, be it at the home or in a factory or in a warehouse. And depending on what is happening or what is the value that we are trying to replace, a form factor will emerge that is a winner. If you're picking heavy payloads and moving from point A to point B to point C, a particular form factor will make sense. Human form factors are not great at doing that. We will not evolve to really pick tons of material and move from point A to point B, right? We invented the wheels, let's use wheels, right? And there will be a machine that effectively utilizes wheels and have intelligence to do that. From CynLr's perspective, what the way I see it is we've been focused on doing this automation of object manipulation, which Gokul keeps referring. And there are certain elements of the form factor that we think is quintessential to automate universally object manipulation, right? You need to have typically more than one hand, right? Most of the times, most of the tasks require two hands. And when you're doing with two hands, you need certain force sensory infrastructure where the arms can know each other's forces, and like they respond to each other when they're interacting with each other. You need to have dexterous fingers. Some level of dexterousness need not be 5 fingers or need not be 2 fingers, but some level of dexterous fingers with grasping and understanding of force while grasping. And most importantly, you need a very scalable vision system that's able to look at objects at different distances, be it a close object or a far object, accommodate lighting variations, accommodate environments. These are all things that naturally occur in any environment, factory, warehouse, or home, which will affect the machine to be able to universally manipulate that object. And from that point of view, we have gone ahead and uh, work top down to figure out what would be an ideal workable form factor. Uh, Not necessarily blindly say, hey, humanoid is the most workable form factor. We need minimum two hands, we need minimum 2 fingers in each hands, and we need a vision system. And that's a workable form factor for universal object manipulation.
Workable, when Nikhil is mentioning workable has a lot of angles and aspects also towards it. Like, will it work for next 5 years? Will it be within the price point of what customer can give? And we also operate within our constraints and what's possible in the ecosystem, right? So that also includes in this factor. Sorry, yeah, go on, sir.
Yeah, so that's how we've looked at form factor. I think it would be a mistake for the industry to fixate on a form factor first and then search for utility of the form factor. Let's work backwards. We see, okay, if there are 5 million pairs of hands doing manipulation tasks in factories, and if, let's say, a company like us can provide 5 million pairs of hands with eyes, that's a good form factor to be in, right? And that's something that will keep us busy for the next 10 years, at least. And then there will also be, a requirement for maybe there are 300,000 workers running forklifts. Um you don't have to put a worker in a forklift, right? You don't have to put a
A
humanoid in
tugger
a
is enough,
forklift. You'll
yeah.
have to put
Yeah.
a tugger would make sense. And these are all terribly large independent problem statements. And we built the dishwasher not as a humanoid, right? We built the dishwasher as a dishwashing machine, which washes dishes in no way similar to how a human would wash. But you know what? That's the staple machine that's available in every household right now, and not a humanoid, right? So
Okay, very interesting. Um, I want to get into sort of the last section of this conversation. And for that, I'm going to switch to some takeaways from your experience as deep tech founders, and that too largely based out of India. And we can get into Nikhil moving to US, establishing an R&D in Switzerland, as well as part of your experience and takeaways. Um, but one thing I've been curious about is from building a deep tech startup venture point of view, how important is it? And did you even have at that time, since you mentioned your seed deck and how it's relevant even today, did you have that lab to market plan laid out in front of you? And how important is that, especially in the deep tech context?
I think we came from market to lab. So in our case, we are not an academic PhD. We jumped out of an academia. We had something that we have absolute expertise over. Then hunting out where can we apply it. We started with the customer's problem. We were customers. Like, in fact, it's a bit of a personal story that I keep saying everywhere, but I mean, I don't have the clarity that I have today. But for me, I started as wanting to build a robot for an agricultural purpose in my home and so on and so forth, and then worked backwards from there, and then understanding how large a opportunity it is, and yet why robotic arms are not so cheap for us to kind of make it. And then also somehow I understood what is difference between a product and a project that you may actually do, which most of the times when you step out of an academia, you don't make you don't realize it. The product is supposed to work without you being there, right? And in a project, you will always have to be there to make it work, right? So that's a very big difference, right? So, and considering all that, then we ask the question of if industry in itself is not able to afford robotic arm, then there must be robotic arms utility must be so limited that they are not able to adopt in wide cases. And many times in even India, we have this thought process of low cost technology, low cost technology. There's nothing called as low cost technology, right? So low cost comes out of volumes in many cases, right? And that is a bigger driver. Volumes are basically customer demands. Customer demands are basically how widely utilizable is your product. So which means somewhere your product is not going to a wide utility. And he worked backwards from there, right? It could be robotic arm, it could be something else. So for us, it's a market to lab, then lab to market. In fact, before, like Nikhil was mentioning, before we came into starting CynLr, we did 4 years of work trying to solve all the unsolved problems that the industry had with a thesis that we had in our mind and an approach that we had with vision, and looked at what the customer problems are, what is commercially viable. And then only when we had 30 systems that we could commercially successfully deploy, we took that as an experience back to the investment world. I mean, again, those commercial success deployments are also because how we subsidized it and then how we did it and so on and so forth. But in our best interest and then a way we could actually think at the point, and that's how we did it, right? So, but what we were sensitized is to the customer's problems, and technology often is not about making a machine work; it's making a customer's ROI work, right? So if you think backwards from that, the whole technology that you will apply will look very different. It'll not look. It may not take a humanoid form factor for that case, right? So, so we worked backwards from there. So we are basically a market to lab story than lab to market story. So for us, it was very clearly like we started with a fixed price point. What is the price point that we should work with? What technology can make us help build that within that price point? And of course, we had deviations from that value. It will be a lie to say that, oh, we exactly had it within. So we started with 60 lakhs as a price point, and then 60 lakhs couldn't give the value that the customer expected for the 60. Then we looked at what is that value that we can actually infuse into that 60. And then if you have to have all the value that the customer asks in that system, what will be the price point? And then work out a model back again to say for the price point what is going to work. But we had that clear notion of what is the price point within which we are supposed to work. And that was not low cost even at that time, right? We looked at what are the utilities where the customer can profitably use the system given that cost. And the other thing we also practically had is we are a very nascent tech. And one. Second, we have low volumes. In all these cases, customer must be able to adopt it. So it's always Roadster first. Tesla Roadster first before you can go to Model S or Model 3 or whatever that it's called, right? So the cheaper ones, right? So we wanted to, you start with premium before you can go into the economic models. Except the framework should lead in volumes to the economic models later. So that's the approach we took. And I think it's very, very important and essential. Otherwise, most of them are left to serendipity, especially in deep tech spaces. And considering the amount of barriers that we face and difficulties that you have to cross through, it's important that you're prepared for it. You may not be successful with it in the first shot, but you'll know quickly how to kind of recuperate with it because you know you're the only difference between a mistake and an experiment is you know that it's going to fail and you're prepared, right? So that clarity we both of us had. We were very strongly inclined from that front. And plus, I think NI's training also helped us to get there. A lot of our learnings happened within that organization for us. So yeah. So Nikhil, then.
Yeah, to add to that, I mean, Gokul has this very beautiful framework that I've grown to kind of imbibe for myself as well, right? So he always approaches things in a very helical way rather than a linear way. So it's not, hey, this is lab and then the factory, then the market. It's always, we keep circling around. So start with the market, learn some problems, bring it to the lab, fix some of those problems in the lab, kind of productize it, take it to market, test it, and then we actually discover something else, come back to the lab. So it's like, from a top view, it might appear like we're going in circles. But if you just look at a perspective from the side view, we are actually going in circles, but we're also climbing up, right? So the orbits are
Moving forward.
constantly increasing up. And that, I think, is a very powerful framework for deep tech interventions. The more linear lab to market might work better for if introducing an existing technology or an existing application in a new market. In those cases, yeah, the traditional framework of go to market fast, like do a lab thing, then test it and then scale. So it's never linear for us. So again, you might have sort of recognized that also every time you've spoken to us. we've never been not doing a customer pilot or not solving a customer problem, right? At the same time, we've always been solving newer, grander challenges. Initially, we solved a lot of those vision challenges, then the grasping challenges, then the dual arm challenges. So each time you would see, and each time you've come to our facility, you would have seen something dramatically better. But organizationally, we are pretty much doing the same thing. We're talking to a few set of customers who have a large problem to solve. We're running those pilots live, funded by the customer, and then we have a R&D team that is like, really innovating from scratch. The problem statements are constantly like, going one notch more, one notch more. So it's that helical process that has kind of driven us, which, over that 5 years, that we've 6 years that we've spent, another 4 to 5 years, what we would have achieved in a decade would, we hope and we believe, would be tremendously more than just a simple linear, we think something in the lab, take it to market, come back, right? So
Can you talk about the brainstorming that led to establishing an R&D center in Switzerland, and any early lessons or takeaways from that experience so far? How is it helping? Any surprises, good or bad?
For me, just came from a very simple factor: brain drain. Right. So more than that, in fact, associated with this is a one more deeper fact that in India, it's basically a talent hunt, because of which we set it up. I mean, at the end of the day, if you are going for setting up an R&D, which means talent is the major reason why we are doing that, right? So, um, the point is, India has a problem of, all the top tier. We have very good B.Tech segments or the undergraduate segments. We do not have really world class standardized um, uh, research and master's program coming out of India, right? Specialization programs coming out of India. And somehow that has always been under focused. And we have seems like the whole system, HRNC, the whole system has taken it for, they have made peace with it. And they have, in fact, started monetizing that factor. Colleges putting that these many people went into MIT, these many people. Colleges are not proud of the fact that these many master's programs we have offered, and then so many of our BTechs have been converted into masters and they have gotten into the industry and then we have set up something, right? So this is how the institutions are also, not even IITs are, forget about the, I mean, IITs is what we call as premiums, right? So, specialized, very few specialized organizations like TIFR, IASC, triple ITs recently to some extent that their MTechs are valued really high. All the other places haven't, right? We have succumbed to this foreign pressure. And more than foreign pressure, the people's desire to have the foreign degree holding. And what happens is, we have just become a medium for resume building for most of the talent for them to get a career in abroad. So this is the biggest problem for me. And on the other hand, I'm not operating. What I'm building now is not a company. I'm building now is an industry. And why do I say that? uh, Robotics have always been an underlying extension of another industry. Whenever they make a progress, right? It's an application of another industry often, right? Motors, ABB from motors to robotic arms, Fanuc from CNC control to robotic arms, right? So, and then for customers, it's an automation, extension of an automation. Instead of a conveyor belt line, I have a robotic arm line. So, it has never been an independent industry by itself, which means you do not have tools to build the company. Industry is the one often that supplies tools that are needed for you to build an company, including all the procedures, know-hows, processes, tools to operate those processes, people with skill set to operate those processes, management principles. None of this is actually available for you. And supply chain, ecosystem, talent pool, none of this is available. So, which means I have to build from scratch, which means I am spending a lot of man hours in training all of these resources. At the end of all this training, if it takes close to around, first is unlearning process, then it's a, so right now when I run an induction, I personally spend more than a month, 8 hours every day in doing induction as an organized class with all of these guys. That's a lot of time a founder has lost from not running the organization. This is the barrier that you have to cross through. And they're not readily aligned, both from an business empathy point of view, that the industry job alignment point of view, and neither in the technology segment, right? Now, all this is lost and drained to another organization to benefit from 2 years down the line. And for me, it starts. I can start monetizing all this only 1.5 years to 2 years down the line, right? One. Now, okay, then why do you do this? Go and hire an experienced folk. Which organization provides these foundational technology building experiences to individuals, right? I mean, this is an argument when I say it. Um, People do get offended. I mean, but the first step to fix that is, but I'm the one who's doing something to fix it, right? While people can get offended for it, right? I'm trying to hire those people, hire parallel freshers here, train them in between, because India is maybe a internet software phenomenon. It's not even a foundational software or hardware technology building phenomenon. Not even at the systems level. Germany could be systems level. Component level is more fundamental, right? The basics of motors, the basics of copper, the basics of EMN, all of these things, right? So sensing, imaging, whatnot, all those component level of design. And there is another statement of why not China and so on and so forth. Um, Apart from political reasons, China, yes, the world is made in China today, but the China was designed in Europe, right? And all the foundational design capabilities are much more fostered really well in Europe than even in US. Even all of them quietly have opened up an office in Switzerland, by the way. Right at the time when we were actually opening, or 1 year down the line after we opened, right? For us, that has been more fulfilling, and also to the ones who have taken a risk and then have joined us as employees within our organization, to whom we owe. One of our first investors are my own employees first, right? That we could give them a safe career path, and for the global capability that they have actually built. Just because you don't have a pedigree organization, and that India has a double eye problem. Either you have to be from IIM or you have to be from IIT to be of respectable opportunity in many cases, right? Uh, but these guys are doing phenomenal job compared to many of those. Most of them don't even clear our entrance. Sorry, our interview processes. We have 15,000 applicants this year. We already crossed 9,000. We will have another 4,000, 5,000 to the rest of the year, of which possibly 10 or 12 clear through, right? And these are like global grade, excellent resources that we actually get, right? And it's that tough. And it's our duty also to kind of provide that safe path to them, and that also gives them more trust and then to stay, and incentivization to stay. And then that MS could be through us, the PhD could be through us, the programs could be carried from here to there. One. Second, we also have to have experts coming into the organization, and those experienced resources are not hireable within India. And even if I want to hire, they are exactly the same expenses there as in Switzerland, right? In fact, for me, the architect that I wanted to hire for the software is cheaper in Switzerland than it is in India, right? That's a fact that many of us don't wake up to, and that's true, right? And and it's much more well aligned to the organizational goals. Employment, understanding of employment is not coming from an entitlement, position of entitlement within those spaces in many cases, right? So it's not that it's absent there, it is there, but it's just that percentages are very different from the front. And then you get matured resources also who have dealt with these products, dealt with these concepts. So you either Europe has produced robotic arms, or Japan historically. Only now China and Korea has started doing it. There is yet to one come from US, essentially, right? So, and the hardware space is, because the ecosystem is more equipped to enable to build such kind of products. Europe is more prominent from the front. So that's the major thought process with which we actually went there. Why Switzerland within Europe is bureaucratic red tape, though India is criticized. I think India is way more easier to do business with than it is in I don't know, as a foreigner, maybe it's a misstatement when I make it. I'm not a foreigner, so for me, it might be very easy for me to start setup and then done. By the time when we started, and a lot of cleaning has actually happened, it was much more cleaner and much more easier for us to do it. Whereas the red tape and bureaucratic, barriers that you face within, be it from labor law point of view, company law point of view, retrospective taxing on a loss making company point of view, exit being extremely cumbersome and painful. All these are typical European Union problem. Whereas Switzerland is not part of European Union, very, very capitalistic from that point of view, very easy. Unlike France, where I can't fire a resource for misdemeanor even. In Switzerland, none of that actually is there. And net, though Swiss is called to be an expensive space, my cost to the company is same in Germany or in Munich, which is where I would get most of my other talents from, or it is in Switzerland. So it's exactly the same. So that's another reason why we actually took up. We just had one. I was having one conversation last Sunday with one of very prominent founders in India. And we were like, Switzerland is very expensive. Why did you keep there for your limited money? Why did you go there? Why not Germany or Eastern Europe and so on? So it's also about concentration of talent, where we would get them. What's the cheapest amongst that? Switzerland is, and then most incentivizing, the most welcoming. The government operates like a corporate office. Very, very incentivized to kind of mobilize things for you. So that those are factors that, and plus also has put us. We are less known in India. We are more known in Switzerland. We are almost a poster child for Swiss government also in a way where they see this as a, they treat as if we are actually an Swiss company in many cases. So those kind of motivations give put us in a global spotlight a lot more. Our penetration to US and rest of the other Europe has happened on the backs of Switzerland. So those, even Japan, our penetration into Japan happened through Switzerland and Swissnex from that front. So it was more helpful for us from that end, and it still is paying us from that factor. So that's why.
Okay, really interesting. Getting into Japan via Switzerland. Who would have thought?
Yeah, we never imagined that would happen. We didn't plan this. It happened, but so
I'm pretty sure it's a whole conversation in itself. Mental
yeah.
note for another podcast episode on that one. Okay, one or two last questions, and the next one, staying on the topic of takeaways for others to learn from. In deep tech in general, and definitely in India, until very very recently, funding, even as a sort of interested tech reporter, I can also see that it's super tough. But you guys have actually done the 10 million round about some six
At
eight
least.
months back. So
Yeah.
can you give other sort of aspiring deep tech founders a sense of what are some of the factors that enabled you to crack that 10 million funding round, and I'm sure it is kind of now setting the foundation as you go along, and that will probably in the foreseeable future for larger rounds.
Yeah, I mean, so one of the things that, in terms of, when we're as an entrepreneur looking out for funding, I think we should keep reminding ourselves as that funding is for us to enable us to build the core idea that we have, or the deep tech innovation that we have. And what that means is that the most obvious sources of funding might not be the right funding sources for you or for that particular company, right? And it While there is a lot more deep tech funding today, it might be also not completely true that for your deep tech venture, funding is ripe in the traditional VC world, right? On the traditional articulated or media covered VC world. And what we've kind of, by chance and like by a lot of effort, so we had to take in each round of funding at least 150 meetings to kind of figure this out. What really worked for us is that at the end of the day, uh, we we ended up finding these partners in VC funds that also happen to be kind of innovative in their own regard, very very
Ashan.
different from what the market really is, right? So Special, for that matter, who was our first investor, all of their investments look very different from what VCs are investing in, right? So, and that DNA, and it could be sector dependent. So, of course, Speciale might not invest in every deep tech sector, might not be interested in every deep tech sector, and some other deep tech investor might be really invested in. We did that mistake that we started with the usual suspects and spent a lot of time convincing the usual suspects, and always what would happen is they would be interested in us as founders, but it'd be very difficult for them to kind of buy into our way of thinking and our way of building. which is necessary for the deep tech venture that we are building, right? So always, like, it would be an advice, come up with this model that is more favorable for my IC, etc. It it your answer might, I think we should not chase just because the name is a brand name.
The big ones, especially the big
Yeah.
names,
So we
especially
kind
the
of look for that DNA matching. I think there is a good flavor of characters in the VCs and the partners in the VCs as well. There are people that like your style of thinking. There are people that like your way of working. And it is an effort to kind of pick out that needle from the haystack, because there will be few and there'll be too many people talking. And I think the pursuit for entrepreneurs should be to figure out that person in the other VC, and whether they are able to align with your way of thinking, and not really change your way of thinking to go and, like, convince a VC to put money, right? Because if you do that, you might not end up building what you wanted to build, right? You might end up building something different. It is going to be hard and a patient game to raise money. So each of our 3 rounds have taken us a really long time to find that like-minded, like wavelength partners to sign up with.
So I think some lessons to kind of pick, uh, at least, which is not applicable to every further round. So whatever that I learned in seed is not usable for me in my series B or next round that we are supposed to raise. So we will discover that, and then in the next one. So one, second, you're going to take an insane amount of time. Start early, and you will never have an advantage in the table. And third, if you see a VC with a template, please don't touch them. Just stay away. Practice untouchability. This is the only place where it's applicable. All right. So, because they are looking at a trend, they're looking at a framework. For a deep tech, you can never, first of all, this deep tech is a word that is a lot of them masquerade as one. It is not a very clearly distinguishable segment, right? And VC mentality is always to kind of have a template to basis to invest. A person who is not coming from a background who can dissect and understand how this would be very different as a model and the businesses would evolve into, because the technology is fundamental infrastructure. It's a fundamental infrastructure. Each of them operate very distinctly different from each other. An automotive fundamental infrastructure may not work for you can't borrow an electronics industry's principle into an automotive industry, but both of DTech, right? And IC manufacturing goes through entirely different stages, and a space will go through entirely different stages. Like one of the statements that often you will have is, what is your technology readiness level? uh, I mean, where are those bullshits coming from, right? So, how are you even assessing? Is it a template taken, out of context? Yes, it's NASA. Yes, it's coming for a space tech point of view, but what is it, right? How are you even templatizing it for an automotive system or for a manufacturing system? Are you operating at a foundation tech level? Or are you operating at a supply chain level or as a business model innovation level? So, what is it, right? So, there are a lot of these hammers that they carry with, and they want to smash you under that hammer, right, and make you a nail. So be careful on those fronts, right? Doesn't mean that you will find who matches you. There's nothing like that, right? You have to kind of evolve to that point. You have to kind of evolve to that clarity on your side also, what you have to transform yourself into. But except, see whether the transformation is to get to achieve closer to your goal of what you are envisioning. Or is it that you are trying to harvest a market, harvest a trend? Many of the VC principles are coming from harvesting the trend point of view. So I have templatized a method of harvesting it. Can you build a system to harvest the trend? So they are funding rain mushrooms in many cases, and I don't believe that only 6% succeeds. 94% is because of these mechanisms. Oh, AI is now a trend. Whole bunch of startups who can actually take it to the market. So all these VC funding um has been market expansion, funding market expansion for technology built by the big segments, big organizations. So Google, Sequoia at one point of time, invested and built these Googles of the world, Googles, Amazons, whoever that they funded, I don't know, but all of those, and then now to expand the market for those products that have been built, a whole bunch of startups have come in terms of app segment, SaaS segment, and so on and so forth to kind of percolate and penetrate them. Are you being bucketed into the template, or is someone funding to build you into that one independent segment? Deep tech cannot imagine from a services expansion business point of view. It is a fundamental infrastructure building setup that has to be imagined very clearly. On the other hand, we have to be pragmatic about the situation that the VCs face also. Is it a VC business in the first place? Right. So I think that is a hard realization that I also ask myself. We somehow crossed and then have come here, but at an early stage, should it have been a more university funded PhD program, and then you come from there, or government funded things and so on and so forth? But even that doesn't make sense in many cases, right? So in certain ways, what Sam Altman said is very true. He has been unfairly. There are 1,000 other things I may have criticism about it, but about him. But that one aspect that he actually said, from India, imagining an open AI to come about, that is not possible. And what he actually said is not that Indians are incapable, that the VC market doesn't have the patience to fund for 15 years, $10 billion or $1 billion to be put into that, or 10 years, sorry, not 15 years, 10 years for you to be able to put into that and then have the patience for it to be built out of it. Do we have such a fund available in India? Do we have a fund available to that quantum in the first place? Is that the right geography that you want to start at? Right. So that question remains true for, though there is reverse flip and everything that we see into the India market. This question remains true still for deep tech, and deep tech cannot have localized markets. Deep tech will have global markets, which means your supply chain is global, your expenses are global. That's another factor that we should remember, right? We raise in INR, we spend in dollars, right? And that's an unfair thing. And you will certainly face an India discount. आप तो इंडिया में काम कर रहे हैं तो it should be lesser expenses for you. It should be so and so for you. Well, Indian market is smaller for you. There are 1,000 reasons by which you will be valued less. Forget the valuation. You will not get the right fuel needed for you to move the organization forward. So your goal consumes this much fuel to get to the destination. And a lot of times this is what happens now in our. So instead of going to so we have set certain milestones to reach to a target or the end destination, right? Before reaching milestones, right now we are racing to hop from one petrol station to next petrol station, right? That's what is happening more than me reaching one milestone, right? So the milestones have become petrol stations now, which is basically funding and funding out of funding, right? So that is a trap essentially. So all this has to be imagined.
Okay, I think a lot of passionate advice for aspiring founders coming,
Especially deep tech founders.
deep tech founders in your footsteps. But more power to all of you. And just to end, kind of a standard question and bringing back to CynLr's operations over the next, say, 18 months to 2 years, from your commercialization journey point of view, what might be your top priorities?
So first thing is to build capacity so today, whatever that we may have raised, our capacity does not scale beyond possibly $1.5 million to $2 million to address the customers, and which is again a technology problem. And for a long period of time, we have to stay invested into the technology. And that's how we will make it both technology and productization. That's how we will make it more easy for customers to adopt. Our goal is to drive towards break even as much as possible. And break even not from the fact that we want to be self-sustained. Break even so that we can prove that this is a entity that has attained break even possibility. Then start gathering more investments to kind of expand further and further into the market expansion, fuel the market expansion, right, for us. From the front, we need to build capacity towards that, and that's what we would want to kind of focus and raise next round to. And we want to multiply our customer base, take into more deployments, and we need to build capacity to produce one robot per day. So that's where we will aim and focus towards, and the whole organization will move towards being able to produce and sell and build pipeline for one robot per day as a whole.
That's it for today. You can find links to Gokul and Nikhil's bios in the show notes. If you're an aspiring deep tech founder in India, do look them up. We'll be back with another episode of Speciale Focus. Until then, it's goodbye from me, Hari Arakli, and thank you for listening.